Problem number 8, determine convergence or divergence of this series, the sum of n from 2 to infinity and the square root of n squared minus n minus 1 divided by n to the 4th plus n cubed plus 5n squared plus 7. So when I see this problem, I kind of see this and this. Everything I'm boxing is kind of irrelevant in the long run. As n gets bigger and bigger and bigger, n squared will overwhelm minus n and minus 1. N to the 4th will overwhelm any effects that n cubed plus 5n squared plus 7 can have. This suggests a comparison test, and we'd be comparing it to the sum, where just kind of cover up the terms, subtract and add the terms, the less relevant terms in the numerator and denominator. So let's suggest that we think about n squared minus n minus 1 over n to the 4th plus n cubed plus 5n squared plus 7. So compare this to, I forgot the square root here. Compare this to the square root of n squared over n to the 4th, which is square root of 1 over n squared, which is 1 over n. Now, you know and I know that the sum from n from 2 to infinity of 1 over n, we know that this diverges. It's a harmonic series missing the first term. It's going to diverge by the p-series test because p is equal to 1. Any way you want to slice it, this diverges. So at this point, I'm very, very confident that the original series diverges. I just have to figure out which comparison test to use. Will the direct comparison test do it? Will the limit comparison test do it? What direction do we have here? The numerator here is smaller than over here. The denominator here is smaller than over here. That means the direction of the inequality is pointing in this direction, which is the wrong direction for us to use the limit comparison test. Because all we can conclude here from the, I misspoke there. This is the wrong direction for us to use the direct comparison test. All we can conclude from the direct comparison test is that our integral, this integral here, is less than a different integral that diverges. That doesn't tell us whether or not this diverges. So instead, we're going to have to resort to the limit comparison test. So we calculate out the limit as n goes to infinity. Let's call this whole thing a sub n. Let's call any of those there b sub n. So the limit of a sub n divided by b sub n is square root of n squared minus n minus 1 divided by n to the 4th plus n cubed plus 5n squared plus 7 divided by, let me use the square root of 1 divided by n squared form so that I can, everything will be under a square root. So the denominator here will still be n to the 4th plus n cubed plus 5n squared plus 7. Dividing by 1 over n squared, that n squared flips up to the numerator. So n squared times this gives me n to the 4th minus n cubed minus n squared. Square root is a continuous function, so I can move it outside the square root, outside the limit. And so I have the square root of the limit as n goes to infinity of n to the 4th minus n cubed minus n squared divided by n to the 4th plus n cubed plus 5n squared plus 7. And the limit here of this divided by this is going to be 1. Easiest way to see that, these are both polynomials of degree 4. The leading coefficient in each case is 1. And so the limit would be 1 divided by 1 is 1. So square root of 1 divided by 1, this limit here is 1. What can we do with this by the limit comparison test? So if our sequences are positive sequences, they are. If the limit as n goes to infinity of a sub n divided by b sub n is equal to L, in our case L is 1, if L is strictly between 0 and infinity, then a series of an and a series of bn have the same behavior. They both converge or they both diverge. So in this case, because this one diverges, that tells us that this one diverges as well. So what's the moral of the story here? realize these red herring terms, get rid of them to do a comparison test. We have to figure out which kind of comparison test. Direct comparison test doesn't work here, so resort to the limit comparison test. And I suppose just being able to do limit manipulations, knowing to use a limit comparison test, knowing to move that limit outside the square, move the square roots outside the limit, move the limit inside the square root. That will make your life a lot easier.